plus g of x is equal to f of x plus g of x. And my f of x function is x minus 3. And I'm going to add that to my g of x function of the square root of x plus 4. And that's simplified as good as I can get it. And then we need to find the domain. Now the domain is not as easy as it was in problem number 17 of your homework because I have a radical symbol. The domain of my f of x function is all real numbers. The domain of g of x is not all real numbers. G of x has a even radical, and you need to make sure that calculates out to a positive number, and positive numbers are greater than or equal to 0. So in order to find the domain of g of x, because it's under an even radical, I take my radicand underneath and I set it greater than or equal to 0. And I didn't really leave myself a whole heck of a lot of room to work in my video, so I'm just going to kind of squeeze it in this margin up top. You take x plus 4, you set it greater than or equal to 0, and then solve for x. You get x is greater than or equal to negative 4. That's the domain of g of x. F of x, as we said, is just all real. So I'm going to draw that out so you guys can get a nice visual that the domain of f of x looks like this on a number line. It's the whole thing, all shaded in. And the domain of g of x goes from negative 4, including negative 4, up to infinity. The domain of f plus g of x, your new function, is the intersection of the two domains, or the overlap. So I'll show you what that is. The overlap, where they intersect, is right here. So the domain of f plus g of x goes from negative 4 to infinity. Those are the points that they have in common. Those are the points or the places on the graph where they're both shaded in at the same time. And the good news is, once you find that overlap or intersection for f plus g of x, the domain will be exactly the same for f minus g and f times g. You don't have to do that for every single problem. The only thing that you have to worry about is f divided by g of x or g over f, and we'll handle that when we get there. Alrighty, so let's do f minus g of x, which is just f of x minus g of x. And f of x is x minus 3. And I'm going to subtract g of x, which is the square root of x plus 4. I don't need to have parentheses around the x plus 4 function, or g of x, because it has that square root symbol there. If I put the parentheses in just to be safe, that's fine. Just make sure you remove them when you realize that they are not necessary. And just write your final answer like that. And that's as good as we can get it. And easy peasy, the domain is the same for f plus g of x. It's just the intersection of both the original domains. And we found that to be from negative 4 to infinity. F times g of x is really f of x times g of x. And my f of x function is x minus 3. And my g of x function is the square root of x plus 4. And you do need parentheses around the x minus 3 function. You don't need parentheses around x plus 4 because of that root symbol. If you put them in anywhere, anyway, to show that multiplication, just in case, because you're not sure, just realize that you can now get rid of them, because that square root symbol encloses that expression. And you can just leave it just like that. In the domain, we already found it, -4 to infinity. The domain for plus g minus g times g is exactly the same. Now the domain for f over g of x, which I'm going to skip right to, I want to do that right away. It's going to be that same overlap except for whatever makes g of x equal to 0. So f divided by g of x is f of x over g of x. And my f of x function is x minus 3 over g of x, which is x plus 4. And I want to figure out what makes g of x equal to 0 because it can't. So whatever makes it equal 0, I'm going to take that out of the domain. So I'm going to take my x plus 4 under my radicand. I'm going to set it equal to 0. And I see that when x is equal to -4, I get 0 in the denominator. And so we're going to have to take that back out of the domain. So our domain, instead of going from exactly -4 to infinity, including the -4, we are going to take away or exclude that -4 by putting an open parenthesis. And we're still going to infinity. So the overlap looks like this. This is the intersection that we see above. It goes from -4 up to infinity, but we are taking back our -4 because x can't equal it, and that's going to put an open circle there. Let's see, I'm not really, I did erase it. Okay, so we took away the 4. The old domain, the overlap for the intersection, for the other problems was from -4 to infinity. Because -4 makes our denominator 0, we're taking it away. And let's go ahead and do g of x over f of x. G of x is square root of x plus 4. That's now on top. F of x is now on the bottom, which is x minus 3. And once again, we need to figure out what makes your denominator equal to 0 because we can't have 0 in the bottom. This cannot equal 0. X minus 3 cannot calculate out to 0. Our overlapping intersecting domain is -4 to infinity. And we're going to remove whatever makes our denominator equal to 0. So I'm going to do x minus 3, set it equal to 0, and I see that x cannot equal 3. So in my overlapping domain where there is a 3, I am going to take away that value. And we're going to put a little hole there, a little open circle. So the overlap is from -4 to infinity, excluding what makes x minus 3 equal to 0, which is a 3. And our domain is going to be -4, including -4, up to 3, union with 3 to infinity. And let's go back to f of f, or f times f. I just said that incorrectly. It's not f of f, it's f times f. F times f of x is really f of x times itself. And the overlappingness of f of x is just all real numbers. It's its own domain, like twice. The intersection with itself. So that's easy, -infinity to infinity. And then let's go ahead and take f of x and multiply him by himself. And that is going to be an x minus 3 times an x minus 3. And then you are left with x squared minus 3x is -6x plus 9.